Okay, so this is lesson 4.5. We're specifically looking at the cast rule and solving trig expressions without the use of a calculator. So what we're going to find today, we would have learned yesterday as we're working through putting coordinate points on these Cartesian grids and then coming up with the radius from those points and subsequently finding the angle. We would have seen in that experience yesterday that in certain quadrants, either the x component or the y component of that point is going to be positive or negative. And from that, depending on where you are on the Cartesian grid, we get different trig ratios, specifically the signs on the trig ratios, depending on which quadrant we're in. And so from that, we would have learned that certain trig ratios are positive in certain quadrants, and the other two are going to be negative in certain quadrants. And so purely based on the sign of the x and y components of the point or of the terminal arm, right? The components of the terminal arm, I suppose, is a good way to express that. And so we arrived at something called the cast rule, where the cast rule said, down here, we'll start in quadrant 1. All trig ratios are going to be positive, and that's because the x component is positive. Like I've got positive x, positive y. So anything up in here is going to have an x component that's positive and a y component that's positive. And so subsequently, all ratios of side lengths in that quadrant are going to be positive, right? And so when we moved around, we developed the cast rule. So in this, down here in quadrant 4, cosine was positive. And then sine was positive in quadrant 2. And tangent was going to be positive in quadrant 3. And again, purely from the signs of the points, in this case, what we're going to look at today is this unit circle, this idea of the unit circle where this is equal to 1. But the x and y component in this one are going to be negative x and negative y. Okay, and so when I found a ratio of theta for tangent, tangent was going to be opposite over adjacent. And so both of those side lengths are negative, and so subsequently tangent comes out to be positive. Okay, so that's the basis of cast rule. What we're going to do is come down. There's a few ways to tackle questions like this, and I think a few questions that you want to ask yourselves as you work through questions that look like this. So the first thing I want to look at here is I see 4 questions, all of which have different angles. I want to ask myself, how could I produce that angle on a Cartesian grid of 0 to 360? And there's a few little tips and tricks that we could use, right? Yesterday we would have developed, or I would have shown you how to produce the 3 special triangles which are illustrated here. Okay, so we would have had a 45-degree triangle, we would have had a 60-degree triangle, and we would have had a 30-degree triangle, right? And from those 3 triangles, we can produce 12 angles around 360 degrees. Each one of these can produce a triangle in this quadrant, this quadrant, this quadrant, and this quadrant. And so subsequent, when you compound that over 3 of them, you get 12 possible angles that we can produce from 0 to 360 with these 3 triangles. 4 of them are right here in this question. So the first question you want to always ask yourself, and you could draw yourself a sketch to help, is where is 315 degrees? Well, if this is 0, I'm going to go all the way around. You remember yesterday we discussed going in the counterclockwise this direction as being positive, and the clockwise direction being negative. So what I'm interested in finding out is which of the three triangles I would need in order to produce 315 degrees. So what I'm going to do is draw myself a terminal arm. And I know it's going to be here because from here to here, 315 degrees is a pretty big angle. And so the way I could produce it is if I made this a 45-degree angle, because 0 and 360 are the same, they arrive back at the same spot. So if I did 360 minus the 45 that's on this terminal arm, I would arrive at 315. And so those are your two kind of challenges, right, to start off these questions. One, where's the angle, right? Like, how do I draw 315? And two, the second decision you need to make is, what triangle am I using? And a lot of the time, if you see a 5 in the angle, the only way to build that is with the 45-degree triangle. So once we've arrived at where we think our angle is and which triangle we are going to use to produce it, I can subsequently put on my side lengths that we would have learned from yesterday's lesson, right? So I know on the 45-degree triangle that's built with a positive 1 in the x direction and a negative 1 in the y direction. That's how you would get down into here. And then you're going to have the square root 2 on that triangle as your side lengths, right? We know, just as practice, so I know in that quadrant, what would be quadrant 4, the tangent is going to be negative. And it is negative because I drew a very accurate diagram or picture. But when I go to evaluate the tangent of 315, which is this 45-degree triangle, this is going to be the opposite side length, and this is going to be the adjacent side length. And I know tangent is opposite over adjacent. And so I know that the tangent of 315 is going to be negative 1 over 1, which is just negative 1. So it comes down to a few steps, like maybe 4 steps, right? Where 1, I'm going to draw myself a picture. 2, I'm going to identify for myself which triangle I'm going to use. 3, I'm maybe going to put the side lengths on and make sure that I've put the correct signs on each, I suppose, leg of the triangle. And 4 is then to mark the angle of interest as the one that is closest to the origin or the terminal arm that makes an angle with the x-axis. And then write out my trig ratio and corresponding to that, right? Well, labeling my side lengths as opposite adjacent and just creating the trig ratio based on which one it's asking for. Okay, so when I do the cosine of 135, again, we can run through the same few steps. I would draw myself a little picture just so I knew where 135 was. Okay, 135, again, I see a 45 in that, or sorry, a 5 in that angle, and so I know the only way I can build that is with a 45. I know I have to go in the negative x direction, right? And I know the side lengths are going to be negative 1, 1, and root 2. And so the cosine of 135 is going to be adjacent over hypotenuse. This is adjacent. This is obviously hypotenuse. And so adjacent over hypotenuse in this question is going to be negative 1 over root 2. And there's something that we've done before, just from a math formality perspective, is we do not leave radicals in the denominator. And so we're going to deal with that by multiplying by root 2 over 2, or root 2 over root 2. Then I know root 2 times root 2 is just going to be 2, or root 4, and the square root of 4 is 2. And so I just get negative root 2 by 2. is going to be the cosine of 135 degrees. I know that cosine is supposed to be negative because we're in that sine quadrant in cast. Okay, the cosine of 240. Okay, picture. You draw yourself a little picture. Ask yourself, where's 240 degrees? 240 degrees is going to be 60 degrees away from 180. Okay, and if I put the 60-degree angle in there, then the 60-degree angle goes opposite the root 3. And if you are new to this, or something maybe you haven't realized coming from grade 10 math, is that the reason the hypotenuse is always the biggest side length is because it's opposite the biggest angle in the triangle. The biggest angle in that 30, 60, 90 triangle is the 90. And so we always put the hypotenuse, or the biggest side length, opposite of the biggest angle, 2 in this particular triangle. Okay, and then subsequently the smallest angle goes opposite the smallest length, side length, which is 1. And then the middle angle goes opposite the middle side length. And so now once you have your triangle labeled, I've missed one component of this, and it's that I went in the negative x direction and the negative y. So I know I'm in that tangent quadrant, right? So tangent's going to be the only positive one in this situation, right? The only positive trig ratio. And so what we have here is I'm looking for the cosine of 240. The cosine of 240 is going to be adjacent over hypotenuse. So -1/2. So the cosine of 240 is going to equal -1/2. These ones that come out to be -1/2, they're kind of nice that you can check your work at home by typing the cosine of 240 in your calculator. You would get -0.5 as your answer. It's a nice way to check. Some of the other ones are a little trickier to see because you don't necessarily know the square root of 2 divided by 2. So that's a little tricky to check, but cosine of 240 should be -0.5 when you type that in your calculator. One more. So the sine of 300. The sine of 300, we got to go and find 300 degrees. Right? 300 degrees is going to be way over here like this, right? How far away? Well, it's going to be 60 degrees away from 360. And so we're again in the situation of 30, 60, 90 triangle, specifically where the 60 is, the 60 degree is the angle formed from the terminal arm to the x-axis. So that makes that 30, 1√3, 2. And if I'm interested in the sine of 300 degrees, sine is going to be opposite over hypotenuse. So katoa, right? That's all we've been using this whole time. And so the sine of 300 degrees has to equal, and again, I forgot to do one thing. Okay, but this is pretty typical, right? Even though I forgot to put on the negative for the y component, I still knew that my answer was going to come out to be negative because I'm in the cosine quadrant, where cosine would be the only one that would be positive. Okay, and so the sine of 300 has to be -√3/2. Okay, I'm going to hit pause there. That's a quick synopsis of the cast rule and finding specific trig ratios. What we're going to do in the next part of this lesson, it'll be lesson 4.5 part 2, is we're going to actually start evaluating expressions that have multiple trigonometric ratios in them. So something like this. Okay, So we're gonna hit stop there. That should give you a foundation, and I'm just gonna do part 2 in a separate video. Okay, so hopefully you found that helpful.